Okay, to do the example, I need a definition. The definition of the average value of a two-independent variable function, f of x, y, over a rectangular region R. And that average is equal to 1 over the area of that rectangular region, denoted by a of r, times the double integral over r of f of x, y, dA. So that is the definition of average value. I'll use it to do this example. The contour map below shows the snowfall in inches that fell in Colorado on December 24th, 1984. Estimate the average amount of snow that fell in Colorado that day. Okay, take a look at the contour map. There it is. It just gives snowfall amounts. So in this area, 2 inches of snow, 4 inches of snow fell right here, all along this contour. And I'm going to use that. I don't have a formula for my function f of x, y, but I do have this map that I can use to estimate function values with. And I need that because I'm going to use these function values to create a Riemann sum that will allow me to estimate the value of this double integral, which in turn will allow me to estimate the average amount of snow that fell. Okay, so if I haven't said so yet, the function values on the map represent f of x, y. Okay. So how can I break up the map in such a way that I can take sample function values? Well, I'm going to use 16 subrectangles. So here's a map where I broke up basically the state of Colorado into 16 subrectangles, and I took middle points as my sample points. And my function values, well, I'll have to estimate them. For instance, for this middle value here, I see that this contour is 0 inches, this contour is 1 inch, so I'll take maybe 0.4 as an estimate of my function value here. Here I'll take 0, 1.2 perhaps, or actually 0.1, I should say. And then here would be, okay, this point right here is in between a contour of 1 and a contour of 2, so maybe 1.8 for this one. Okay, and then so on and so forth. You can get all your function values for all 16 of them by just looking at the contours and coming up with your best estimate. Okay, so how can I come up with an estimate of that double integral? Well, first I need delta A, the area of each sub-rectangle that I've come up with. And in order to get delta A, I need an estimate of the entire area of the state of Colorado, which, using the language from above, that's just A of R. Okay, it turns out the state of Colorado is, as I've shown in the map, it is a rectangle, and it measures 388 miles by 276 miles. So this is basically given information. So that the area of the entire state is 107,088 square miles. Okay. That means delta A, you can get delta A, since I broke up the map into 16 subrectangles, I can take 1/16 times that area I just found. And get 6,693 square miles. So that if I want to estimate the double integral over R of f of x, y, dA, I can just take delta A times the sum of all the function values you get from all 16 subrectangles by plugging in these middle values. So I've already given you 4 of them. The first 4 are going from the lower left on up. 0.4, plus 0 plus, I used 0.1 for the third one, plus 1.8. And then, okay, starting from down here going up, I used 1.2 here. And like I said, going up, the next one I got 3.9, 6.1, 8.0, plus 1.8, plus 4, plus 16.5, plus 16.2, plus 3.9, plus 6.5, plus 8.8, one more, plus 9.4. Make sure there's 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that turns out, well, delta A is just the 6,693 number that we already computed, and then that sum in the brackets turns out to be 88.6, so that I really don't care what that product is. I just want to compute F average, which is going to be the product from above times 88.6 divided by the entire area of the state, which was, that's A of R, which was 107,088, and this is really approximately equal. That turns out to be about 5.5. So in conclusion, you can say, so on 12/24/82, Colorado got about 5.5 inches of snow on average.